What's up, dudes? My name is Ben, this is David, and the one filming is Richard, and today we're going to make a video to teach you about Newton's laws.
As Newton's first law stated, every object has a tendency to stay in its current motion. This is called inertia. It's a tendency for its object to stay in rest or uniform motion, unless it's been act upon an external force.
This demo is a very simple demo, and it shows that objects are very lazy. They like to stay in constant state of motion. So, bigger objects, such as this wall, do not like to move. And smaller objects, such as this flower, can be moved very easily.
This is our demo for Newton's first law, inertia. Richard will demonstrate inertia of bigger objects to smaller objects.
As you can see, this wall seems to be pretty heavy. Okay, and I will try to push on it and see if it moves. Okay, it doesn't move. Now, let's try this flower. It seems pretty light. It moves!
Okay, now we'll talk about Newton's second law.
The Newton's second law stated the force acting on an object is dependent on its mass and acceleration of the object. It can be shown as F equal to ma.
In this experiment, we are using a ramp, which is here, and a block. We're going to drop two balls from this ramp, one heavier than the other and one lighter than the other. The metal ball, which is here, is clearly heavier than the ping pong ball, which is here. So first, we will drop a metal ball. As you can see, it has moved quite a bit of distance from its original point. Now we'll move it back to its original spot and drop a ping pong ball. As you can see, it barely moves.
Okay, as you clearly saw with our last demo, it demonstrates that force equals mass times acceleration. When the heavier metal ball hit the piece of wood, it moved farther because its mass is greater. Therefore, it hit the wood with a greater force. When it hit the when the ping pong ball hit the piece of wood, it had a smaller mass, which means that it hit the piece of wood with less force. Yeah. Okay. Now for our final third segment, we're gonna talk about Newton's third law, which is for every action there is an equal and opposite reaction.
So for this demonstration, we will show that every action has an equal and opposite reaction. My partner here, named Ben, will demonstrate. I will push against him and he will try to stay still. As you can see, we both fall back. Why is that? Because when I push, his hands exert an equal and yet opposite reaction, meaning that it is equal magnitude but opposite direction. That's why I fall back the opposite way he did.